All right, so when we are graphing rational functions, we're going to start off in these first 6 examples by finding the X-Intercept, or septs, the Y-Intercept, if there is one, vertical asymptote, or totes, and then the domain. And then we're going to take it further in some following examples and do some horizontal asymptotes and all that kind of good stuff. So we're going to start with this one. And I'm just going to do the same order for everything each and every time. So I want to find X-intercepts first. So notice, and what if I forget to say it? Boy, how do you remember it yourself? You should always try and reduce first. Okay, so it may be in factored form, and it may not be in factored form. But either way, if it's reducible, we would need to reduce first. So this is not reducible because we do not have common factors in the numerator and the denominator. So remember that this represents a single number over a single number, if we knew what x was. And so if I want to find x-intercepts, the way that I do that is recognize this is a fraction. The only way to make a fraction equal 0 is for its numerator to equal 0. So the denominator is still there, I'm just ignoring it. Okay, and then I'm going to solve, and I'm going to find out that I have an x-intercept at 1. So my x-intercept is at 1, 0. Okay, now go for your y-intercept. You may or may not have a y-intercept, but we're going to attempt to find them. So how do I find a y-intercept? To find a y-intercept, substitute in a 0 for x's, and then tell me what pops out. So that's going to give me a 0 minus 1 over a 0 plus 2, which gives me a negative 1 over a 2, which is negative 1/2. So I have one x-intercept and I have one y-intercept. If you have multiple y-intercepts, you've done something wrong because that means it wouldn't be a function. So next I want to do vertical asymptotes. Vertical asymptotes are untouchable, and we're kind of going to knock out 2 birds with 1 stone here. And what I'm going to do is I am going to find the domain. So I've got an x plus 2, and that cannot equal 0. Okay, why not? Because if this is 0, so if I've got x minus 1 over 0, I'll be dividing by 0, which is undefined. So my domain cannot include 0. So I'm going to do this at the same time. I'm going to find the vertical asymptote and the domain at the same time because it's the same process. It's just that we make one little tweak at the end. Okay, so my domain says I cannot have my denominator equal 0, otherwise the whole thing is undefined. So I end up subtracting 2 from both sides. So I say x cannot be negative 2. So my domain is going to be everything but negative 2. So from negative infinity to negative 2, and then again from negative 2 to infinity. So if you think about that on a number line, you would have an open circle at negative 2. Well, what is at negative 2 is a vertical asymptote, and that's an imaginary line that guides your graph. So my domain does not include negative 2. Why? Because there's a vertical asymptote at x equals negative 2. So if you put these two things together, you get all real numbers. Okay? So I've got the equation of a vertical line at negative 2. It's an imaginary line that guides your graph. And then your domain is everything but negative 2. You can't use negative 2 because there's a vertical asymptote there. Okay? So let's try it again from start to finish. We have x minus 1. F of x is x minus 1, x plus 3, x minus 5, all over x plus 2 squared times x minus 4. Okay, so this is my function. First thing I'm going to see is does anything reduce? So do I have an x minus 1 on top and bottom? No. Do I have an x plus 3 on top and bottom? No. Do I have an x minus 5 on top and bottom? No. Okay, so nothing is going to reduce, and now we can dive in. So my x-intercepts are going to be found by setting my original function's numerator equal to 0. The only way a fraction can equal 0 is if its numerator equals 0. So the denominator is still there. It's just that we're too lazy to write it out. So I'm going to take each factor and set it equal to 0. And then I'm going to solve. So I add 1. I subtract 3. I subtract 5. So I've got X-intercepts, or solutions, or zeros, at 1, at -3, and at 5. So I've got 3 X-intercepts. Now we're going to find the Y-intercept. How do I find the Y-intercept? I very carefully substitute in a 0 for X, and I see what pops out. So it gives me a 0 minus 1, a 0 plus 3, a 0 minus 5, over a 0 plus 2 squared. Okay, 0 minus 4. So working at that, that's going to give me a -1 times a 3 times a -5. Someday I'm going to learn to start writing closer to the left side of the page. Okay, this gives me a +2 squared, and that gives me a -4. So the numerator of this fraction becomes -1 times -5 is 5 times 3 is 15. So I have 15 over 2 squared is 4. 4 times -4 is -16. So I end up with -15 over 16. So that's my Y-intercept. So my vertical asymptotes and domain, I'm going to find at the same time. Domain. Okay, so how do I do that? I'm going to take my denominator. I'm going to say you absolutely cannot be 0. You cannot be 0. So my denominator cannot be 0. So I'm going to take each factor and say each factor cannot give me a 0. Okay, so I'm going to square root both sides. So I get x plus 2 cannot be 0, which means x cannot be -2. I'm going to add 4, so x cannot be 4. So your domain is going to be all the way from -infinity to -2, then everything between -2 and 4, then everything from 4 on. So your domain is everything but -2 and 4. So what's at -2 and 4? You've got vertical asymptotes at x equals -2. You must give me the equation of a line. Okay, and you've got a vertical asymptote at x equals 4. So these are your vertical asymptotes. If you were to graph that, you would have a vertical asymptote at -2 and a vertical asymptote at 4. Okay, let's do another one. So we have 3x minus 4 over x squared minus 16. So this is not factored form. So look at the numerator. There's nothing in common on your numerator. And it's not the difference of 2 squares or anything like that. So this is prime. I cannot break that down any further. But this is the difference of 2 squares. So this is x plus 4, x minus 4. So he is now in factored form. So we're going to find our x-intercepts first. How do we find our x-intercepts? We grab our numerator and we say, what will make u be 0? And of course, this is after making sure that nothing reduces. Nothing reduces. So I'm going to add 4 to both sides. And then I'm going to divide both sides by 3. So I end up with an x-intercept at 4/3. Okay, how do I find my y-intercept? My y-intercept I am going to find by zeroing out x. So I'm going to shove a 0 in for x and see what pops out. So 3 times 0 minus 4 over, you can either do it here or you can do it here. It doesn't matter. These are the same thing. It's just that one is written in factored form and one is written in polynomial form or general form. So I can say 0 squared minus 16. So that gives me a -4 over -16, which gives me a positive 1/4. Positive 1/4. So let's find our vertical asymptotes. and the domain at the same time. So my vertical asymptotes, wherever my denominator is 0, is where it's going to be undefined. So I'm going to grab this, say u cannot be 0. You could have also grabbed the factored form. Then you could have set each factor equal to 0. I'm going to do square root method. I could factor this as the difference of two squares, and then I would get a -4 here and a +4 here. But I'm going to go ahead and do square root method just for practice purposes. So I have x squared cannot be 16. Take a square root of both sides. So x cannot be positive or -4. Well, that's exactly what I got up here. X can't be -4. X can't be +4. X can't be -4. X can't be +4. So you've got two values. X cannot be -4 or +4, but it can be everything else. So from -infinity to -4, between -4 and 4, and then from 4 to +infinity. That's your domain. That's everything you're allowed to use. So if this is everything I'm allowed to use, I'm not allowed to touch -4 and +4. Why? Because there is a vertical asymptote at each one of those. So these are the equations of your vertical asymptotes. This is your domain. So notice if you put those together, you get all real numbers. All right, let's try 3 more. I'm going to get section 9.2, example 1, done in one video. So I now have f of x equals x squared plus 4 over x squared minus 2x minus 8. So my numerator do not fall into the pit. My numerator is not factorable. This is the sum of two squares. So technically that's prime. That is not the difference of two squares. Do not change that into x plus and minus 2. So my numerator is going to stay as x squared plus 4. My denominator is going to be x squared minus 2x minus 8. I just wrote the whole thing over again. Hang on. Where is my handy dandy toy? I could pause this video and I could rewind it and then make it seem like I never made the mistake. But I don't feel like doing that. So you're going to bear with me through my mistake. All right, so what did I do? I need to factor this. Two numbers that multiply to -8 that add up to 2 are a -4 and a +2. Now, these are the equivalent rational functions. It's just this is in factored form. Okay, so if I want to know X-Intercepts, I'm going to find my numerator and set it equal to 0. So I'm going to subtract 4 from both sides. So I get x squared is -4. Take the square root of both sides. So right now, your brain should be twitching. I see a negative under a square root. So I get x equals positive or negative. Okay. The square root of 4 is 2, and I handle that -1 by writing I. So my solutions are imaginary. I cannot plot that on a coordinate plane. So for x-intercepts, I don't have any x-intercepts because I've got imaginary solutions. I do not have any x-intercepts because I have imaginary solutions. So my y-intercept, I am going to evaluate at 0. So I get 0 squared plus 4 over 0 squared minus 2 times 0 minus 8, which gives me 4 over -8, which reduces to -1/2. So I've got a y-intercept at -1/2. Now let's do our domain. So my vertical asymptotes, and my domain are going to derive from the same place. So I'm going to go ahead and take the factored form, okay? So your domain is wherever your denominator cannot be 0. So I do not want this denominator to be 0. So take each factor and say you cannot be 0. And say you cannot be 0. And then I'm going to add 4 to both sides. I'm going to subtract 2 from both sides. So I've got x cannot be 4. X cannot be negative 2. X can be everything else. Okay, your domain can be everything else. So from negative infinity to negative 2, between negative 2 and 4, and then from 4 on. But remember, you're using parentheses or soft brackets to indicate that you can't touch the negative 2. You can't touch the 4. Because what's at negative 2 and what's at 4? At negative 2, you have a vertical asymptote. So this is the equation of a vertical line. At 4, you have a vertical asymptote. So that's the equation of a line. Okay? Let's do it again. So I have f of x equals 94 minus 2x squared over 3x squared minus 12. Okay, so first of all, on the top, I know I can pull out a 2. So that's going to be 45, 46, 47. So I've got 47 minus x squared over, so this is not really the difference of 2 squares, but I'm going to show you how to manhandle them in a second. What's common down here, I can pull out a 3, which leaves me with x squared minus 4. So that is the difference of 2 squares. So this is the difference of 2 squares, but that's not a pretty square. So I end up with 2 times 47 minus x squared over 3 times, this is going to be x plus 2, x minus 2. And something kind of cool happens up here, so I'll show you that in a second. All right, so x-intercepts. Hey, how about I show you that now? X-intercepts are going to be wherever my numerator equals 0. So grab your numerator and say, hey, what makes you 0? Remember, the denominator is still there. I am just too lazy to write it, so it's in my way. So I'm going to divide both sides by 2, which gives me 47 minus x squared is 0. I'm going to add x squared to both sides. So I get 47 is x squared, and then I'm going to take the square root of both sides. So I end up with x can be positive or negative root 47. So I've got 2 x-intercepts. They're ugly. They are ugly x-intercepts. So I've got a negative root 47, comma 0, and I've got a positive root 47, comma 0. Okay, so this is what happened up here. I still had the difference of 2 squares, so I could have factored that as the square root of 47 minus x and the square root of 47 plus x, and then when I've set each one of those factors equal to 0, I would have gotten a negative root 47 and a positive root 47. So this is still the difference of 2 squares. It's just not the difference of 2 perfect squares, because it ended up breaking down ugly. All right. So what is your y-intercept? How do I figure out your y-intercept? We're going to shove in a 0 to the entire equation, and we're going to see what happens. So that gives me a 94 minus 2 times 0 squared over a 3 times 0 squared minus 12, which gives me 94 over 12. Both of those are reducible by 2, so I end up with 47 over 6. So if I evaluate at 0, I get, it's negative. I get negative 47 sixths, okay? If I evaluate at 0, I get negative 47 sixths, because these two terms, I'm talking myself through to make sure I didn't screw up. All right, so those two terms go away, so I end up with 94 over negative 12, which reduces to 47 over negative 6. So what are your vertical asymptotes / domain? And I should have been saying every time, does anything reduce? No, I do not have the same factor in the top and the bottom, so nothing reduces. Okay, so my domain is going to be my denominator, which is 3x squared minus 12, and say you cannot be 0. So I'm going to add 12 to both sides. I'm going to divide both sides by 3, which gives me x squared equals 4. And then I'm going to take the square root of both sides. So x cannot be positive or negative 2. So come back up here and look how that all fits together. If I use this factored form, I could have divided both sides by 3. And then I would have x plus 2 is 0, x minus 2 is 0, which would give me x equals negative 2 and x equals positive 2, or cannot equal. So your domain is going to be from negative infinity to negative 2, and then again from negative 2 to positive 2, and then again from positive 2 to infinity. Someday I'm going to learn to have enough room to write. All right, so if that's my domain, what are my vertical asymptotes? My vertical asymptotes, I'm going to have one at negative 2, and I'm going to have one at positive 2. So those are your vertical asymptotes. All right, last one gives me f of x equals 2x squared plus x minus 1 over x minus 4. So the top of this is factorable, so let's go ahead and factor him down. I'm going to do that by doing the AC method. So I need two numbers that multiply to a 2x squared, negative 2x squared, okay, that add up to negative or positive 1. So that gives me a positive 2x and a negative x. So positive 2x, negative x, okay. And then what's common on my first two, I can pull out a 2x, which leaves me with x plus 1. What's common on my last two, math people do not like leading off negative if we can help it, so I'm going to get rid of it. Pull out a negative 1, and that'll just change the signs. So tell me what is in parentheses. Tell me what is not in parentheses. So my numerator is now an x plus 1 times a 2x minus 1 over an x minus 4. So I've just taken this and rewritten it in factored form. My denominator doesn't break down. So for x-intercepts, I've already done the work. So I'm going to grab my numerator. I could grab this one, but I'm just going to have to factor again. That's why I factored first. So grab my numerator and say what will make u be 0. So I'm going to take each factor and set it equal to 0. So I would subtract 1 from both sides. So I've got an x-intercept at negative 1, 0. I would add 1. So I get 2x equals positive 1. Divide by 2. So x equals 1/2. So I've got two x-intercepts. One is at negative 1. One is at 1/2. I could also call those solutions. I could also call those zeros. So I can also call them roots. Okay, so I've got my y-intercept, means I'm going to shove in a 0, and I'm going to see what pops out. So I can shove it in here, or I can shove it in here. It's equivalent. It doesn't matter. You'll get the same answer. So I have 2 times 0 squared plus 0 minus 1 over 0 minus 4. Oh, you couldn't see what I was doing. All right, so 2 times 0 squared plus 0 minus 1 is negative 1. 0 minus 4 is negative 4. So if I evaluate at 0, I get 1/4. So that's your y-intercept. And now we're going to do the vertical asymptotes. Asymptote, or domain, which means we're going to grab our denominator of x minus 4 and say u cannot be 0. So if we say u cannot be 0, I'm going to add 4 to both sides and say x can't be 4. X can be everything else. Better not be 4. So I go from negative infinity to 4, no touching. Go from 4 to positive infinity, no touching. So that's my domain. What's my vertical asymptote? Because my domain does not include 4, I have a discontinuity at 4. So I've got a vertical asymptote at 4. And that is it for example 1.